to read the screenshot that I put there into Slack. Someone want to just read through that for us? Okay, Matt, why don't you come on mic and walk through it?
Prototype-based programming is a style of object-oriented programming in which behavior reuse, known as inheritance, is performed via a process of cloning existing objects that serve as prototypes. This model can also be known as prototypal, prototype-oriented, classless, or instance-based programming. Delegation is the language feature that supports prototype-based programming, from Wikipedia. As we develop more programs, we run into the concept of dry, short for don't repeat yourself. With dry, we begin practicing the declaration of variables whose values range from arrays to functions, all for the purpose of being able to refer to and reuse these already defined values. However, what do we do when we want to go beyond reusing a value, which may just be a primitive or an object containing some key value data? What if instead we want to clone an object that has behaviors we seek to reuse? For example, say we are developing a revamped version of the video game Street Fighter. Each character may have their own unique fighting tricks, but in general, all character objects should have at least the same kick and punch abilities. With dry in mind, when we develop a new fighter object, we know we would want to avoid recreating any of these general behaviors and instead code a solution that clones them. This solution is performed with prototypal inheritance.
Nice, thanks, man. So just to recap on that last paragraph, kind of the gist of what we're doing today with constructors and prototypes is it's a very dry way of writing our code. For example, if I wanted to represent you 8 students as objects, I could go through and create 8 individual objects, one named Mike, one named Alan, etc. Or maybe I could create one constructor function, one model for each of my students called student, let's say. So let me ask you guys, you can put these answers into Slack. So just for funsies, if I was going to create a model called student that I would base all 8 of you on, kind of as a starting point, what would be some behaviors, properties, methods that you all would have in common? What are some things that you all would share that would be the same? I'll give you an example. So if I was going to create 8 student objects, perhaps class name, if I had a class name property, all 8 of you would have the same thing, maybe WDI or Web Development Immersive. Maybe if I had a property called like length of class, it would all be the same, 13 weeks. What are some other examples of things that you guys would have precisely in common? The idea being that I wouldn't have to repeat myself if I was going to create 8 instances of a student. Yeah, remote. So maybe in class versus remote, all of you guys would share remote. Yeah. Has Mac, true. Does everyone have, yeah, everyone has a Mac, right? That's pretty rare, by the way. There's always one outlier with like a Linux box or something, which is all good, but.
I wanted to do it.
You did? You wanted a Linux? As long as it's not PC based. PC is really kind of a struggle, but yeah, maybe class name of matey. Yeah, nice. These are all, if I was going to create new instances of something, just let me create a student model that I'm going to model all of you after. So that'll save me some, some extra typing, some extra logic and such. Okay, so now let me ask you, what are some properties or methods that perhaps would be different between each of you 8 students? Yeah, name, first name, last name, location, age, maybe prior experience or work history, something like that. Some of you may come from I don't know, maybe you were students prior, maybe you worked in a restaurant prior to the course, all different backgrounds. So that would probably be different as well. Yeah, gender, location, age. Yeah, very good. So as we think about the lessons for today and on a bigger scale going forward, when you start building your full stack applications, particularly when we add a database component, it's quickly going to become inefficient. If you imagine Facebook, so Facebook has, I don't know how many millions, billions of users. So Facebook has to come up with a very efficient way to create new profiles, new instances of a user, or new instances of a friend. What's the most efficient way to do that? Well, they probably have some sort of prototype or constructor method for a profile or a new user. And so they just create new instances of a user. It's a very efficient, dry way to scale up your application. So that's the gist of what we're going to do this morning. And all this falls under the umbrella of object-oriented programming. And let's take a look at sometimes you'll hear this called OOP for an abbreviation, but object-oriented programming in JavaScript specifically. So as a quick review, when we talk about classes in object-oriented programming, we're describing a way of organizing your code in schema. A schema is something that we're going to talk about specifically on Thursday, very database specific. Organizing your code and schema to model real-world problems and data structures in our applications. In essence, we use classes to model the world around us. So we just did that, for example, with a student. So we created a student model that would represent what a student would look like in the context of, GA and WDI specifically. But technically speaking, there are no classes in JavaScript. And that's because even though JavaScript is an object-oriented based language, it is not class-based. That's a little wonky. I think that will be a little clearer as we get into our Ruby coverage later in the course. We're going to revisit this idea. So Ruby is a class-based language. You don't need to worry too much about the particulars right now. But again, the larger idea is that we're creating a model that we can create new instances of something out of. But JavaScript, let's describe it as a prototype-based language. So we can use JavaScript just like we're used to as a class-based language if we think of these things called constructor functions like classes, like so many people do. So again, an idea, some of these words are very, very similar. Classes, models, constructors. There's a lot of jargon in here, but we're pretty much talking about the same concept. Now, the second part of what we're going to walk through today is prototypical inheritance. So JavaScript uses objects, specifically function objects, to perform inheritance. JavaScript has two different features, constructors and prototypes, which accomplish these tasks. So these are the two concepts we're going to be spending our time with this morning. The first one, a constructor function actually manufactures new instances of an object. The prototype property defines the behavior of new objects manufactured by the constructor. So for example, let's go back to the student example we were just talking about. So let's say that we would create a constructor function called student that would create 8 new instances of a student. Now, some of the properties that we talked about, you guys would inherit from that student model. Some of the properties that you would inherit would be those that you share, for example. So you're all going to share, the name of the cohort, maybe. You're all going to share in-class versus remote. Well, you guys are all remote. So certain of those properties, when we create a new instance, you're just going to inherently inherit those. How redundant is that phrase? You're going to automatically have those properties because we're creating a new instance of a WDI student. So I don't have to, if I create a new Sophia object, I don't have to tell that Sophia object, okay, you are a remote student. The name of your cohort is called Matey. You're already going to have that functionality built in because it came with that student constructor, that initial prototype that we created you from. Now, so far, we've looked at one way to create an object. This is the way that we've been looking at all throughout class, and that's an object literal. So hopefully this is familiar. So this is kind of the quick and dirty way to create new instances of an object. So if you look at that example, we have a variable called myObject, and then we instantiate it with the curlies, and then that has one key and then a value, obviously. So I could create 8 new student objects, var Sophia equals this, var Alan equals that. But let's say that I'm creating hundreds and hundreds, millions of students or instances of something. At some point, that's going to become a headache, and it's not going to be very dry. So what we can use is a constructor function. And what a constructor function would look like, here's an example of what that object literal would look like if we wanted to create a constructor function from it. So essentially, we could have a variable called myObject, and then we can use that new keyword to create a new instance of an object. And then after we assign that new object to a variable, we can attach new properties and values using dot notation the way that we're accustomed to. So this is what we're going to be walking through today. We're going to be using constructor functions instead of manually creating new objects kind of the longhand way. So let's actually see an example in action with a person constructor function. I'm going to start sharing my screen, and if you guys want to follow along for some of this, I think the path of least resistance, I'm just going to be doing this in Replit, and then I can share my Replit link if you guys want to grab this code later. But I think that's going to be the easiest way to walk through today's examples. So if you guys want to go ahead and go to Replit, repl.it, and open up a new JavaScript Replit, I'll go ahead and share my screen. Again, you guys are happy, you should feel free just to kind of watch for the time being until we get to an exercise here in a moment. But if you want to follow along, I'm going to be doing this in Replit because I love Replit. Then I'm also going to be popping down here into the DevTools periodically. So I just have this window open, although we're not going to use it right now. Well, let's get started. So the screenshot I just put into Slack, instead of a student, let's say that we wanted to create a person, even a more general type of constructor function for people. So a constructor is any JavaScript function that is used to return a new object. Constructor functions are pretty much just like regular functions, except we're going to throw that new keyword in there to create a new instance of that particular object or function. So a function can be written to be used as a constructor or to be called as a normal function. So there's really not that much of a difference. It's really just the intent of why you're writing that function. So I'm going to write this person function. We'll see this in action. So let me create a person. I'll pass in a name parameter. So I don't want to hard code a name for each person, right? Because we're all unique. We all have unique names. So that would be something that I wouldn't necessarily want to inherit, right? I want each name to be unique. Remember that our functions have local scope using this keyword. So I'm going to keep this really simple. When I instantiate a new person, out of the box, I'm just going to have them with one property with a name property. One other thing I want to note here is in the screenshot, it's kind of a convention that when we're creating a constructor function, that we want to capitalize the first letter of that function. So this is just a convention, but it's a really quick way to kind of mentally note that when we see a capital P function, we know that it's a constructor. So it's just kind of a best practice convention that we want to do. And that's pretty much across other languages as well. When we get to Ruby, even Thursday, when we get to creating more robust models and schemas, we're going to want to capitalize whatever constructor function or whatever model that we're using. And that just lets us know that that's the model for a capital P person. Cool. So this is a very simple example of a constructor function. And then let's see it in action. So let me save my constructor function. I'll go ahead and run it so I load up the script. If you want to take a look at that screenshot, just for example, I'm going to create a new person called Jenny. And the way that I can instantiate a new instance of person, specifically named Jenny, I need to use my new keyword, and I'm creating a new person, like so. And I know that my person takes a parameter of name, so I can go ahead and pass in a name for Jenny right here. And I run that, and then now if I call Jenny, so now I have an object named Jenny. If I wanted to create one named Mark, for example, capitalize that. Can pass in the name Mark for this one, for this instance. And now I go Mark, and this object contained in the variable Mark has a name of Mark. But they're both instances of this person constructor function. And one really quick and handy way to check if a particular object is an instance of something is I could type in Jenny and then an instance of method. So is Jenny an instance of a person? And I get true returned. If I do, is Jenny an instance of a string, for example? That's false, because obviously a string is a different type of object. Every time you create a string, actually, underneath the hood of JavaScript, you guys are calling a constructor function for a string object, and then you create new instances of a string. We're going to take a look at that next. But this is a very simple example of how we can create a constructor function. In this case, we're creating a new person constructor to create new instances of a person. And then the last thing in that screenshot, I just want to bring your attention to it, and then we'll move to kind of a you-do. We use these constructors all the time, even if we're unaware of it. So for example, if I wanted to create a new string, and I'll just assign a new string to that str variable, I can use the string constructor. And I want to create a new string called ABC, or that contains ABC. So now if I call my string variable, this is actually a more complex way of creating a string object versus a primitive. So if I do something like this, so primitive string equals ABC. So I could do this as well. And then it just returns that string ABC. However, when we use these constructor functions, it's actually creating a more robust object of what we're trying to instantiate. So there's the primitive string, which is simply a primitive. But if we use that constructor function for string, we can see that it's a little more robust. So it actually counts kind of the indexes, each character in that string. And we're going to take a little bit of a deeper dive into this later. But I could do an instance of for that string variable, and then indeed str is an instance of a string. If I tried to ask if str is an instance of a person, I get false because that's an entirely different type of constructor. So let's put a pin in it right there. Are there any questions about those few steps? And then I have some constructor practice for you guys.
Yes. Okay. So what I'm not understanding here is in the person, what do we call it? Class, something? Constructor?
Yeah, all of these terms, they're kind of interchangeable. Today I'm going to try to be consistent. We're going to call these constructor functions.
Okay, so I know that you're using the this value and you're setting this particular constructor's parameter name to the name that's being passed in. Mm-hmm. But where is this name parameter or variable or whatnot? I don't see it in here. It's in the person original?
Yeah.
I'm confused there.
Yeah, no problem. So this is a constructor function here on the left. So I'm deciding when I create a new person, this is a model or a constructor for each new instance of a person. So out of the box, I want this person, I want to be able to pass in a parameter of name. so that I can name each individual, go ahead and name each individual person, give them a property of name when I create each new person. So remember that this has local scope. So when I pass in name, if I try to create a new person named Jenny, then when I create that new instance of a person, the name of that object is going to be Jenny, the name property. And I did that right here. Yeah.
Yes. So this is, you're actually adding this parameter using name. Yeah, I get it now. It's start.
Yeah.
Okay.
And consider this. Let me do this one. Let's take it a step back. I could create a constructor function without any parameters, right? Let me create a new instance of a person. Just all I need to do is use that new keyword. So now I have an empty object, name undefined. Actually, I don't think my memory cleared out right there because it shouldn't even have recognized name. Let me try it down here real quick. And I'll just refresh my replit. With this person, since I'm not passing in any parameters, it should just return an empty object when I call mark. Let me try this one more time. Maybe the memory didn't clear out. So let me do a mark equals new. So remember, when we want to create a new instance, a new copy of something, we need to use that new keyword. So I'm going to create a new variable of mark, and I want mark to be an instance of a person. New person, not defined. Let me try this down here. Okay, let's see if it'll work in here. Okay. Yeah, Replit's being a little screwy right now. So here I created a new, I just created an object, constructor function called person. And I wanted to create a new instance of a person named Mark. So with this person, I didn't pass in name, I didn't pass in any properties or anything. So when I instantiate a new person and assign it to the Mark variable, it's just an empty object, right? There's nothing going on here. Now I can go after the fact and I can create a property called name and assign it to Mark. And now that Mark object has a name. But consider that maybe that's going to be, if I wanted to create 8 new people, those are a couple of extra steps that I'm going to have to go through. So maybe I want to create that constructor function. Maybe I want it to look something like this. So maybe I want to go ahead, go up one more. Maybe I want to go ahead and say that I want each person to have a name. And every time I create a new person, I'm just going to have that name parameter be the name property for that new instance. I could also pass in, like location. So maybe I just want to kind of dry this up and have some sort of like, out of the box stuff. So now when I create a new person, I want to give it the ability to pass in a name and location. So let's run this. And let me try this one more time. So I'll do Mark. Remember, I need to capitalize it. So I'll pass in Mark and Atlanta. Cool. And so now Mark, it just saved me a few steps, right? So now when I instantiate a new instance of person, I can go ahead and create properties of name and location for that new instance of a person. And I can still attach other stuff. So I can do Mark, I don't know, class equals matey. And now after the fact, I can add new properties and methods to that object. But if I want to create a template for each new person, again, the idea is to to dry up the code to make this as easy as possible to create new instances of something. I can pass in these parameters that way. Any other questions? I want to give you guys a little bit of practice with this stuff. Okay. So take a look there in Slack. Go ahead and take, we'll take maybe 5 or 10 minutes for this. Just getting some practice in the steps we just walked through, just creating very simple constructor functions. So go into the console. You can do this in your DevTools or you can do it in Replit. And create a few constructor functions like the person example that I just demonstrated. So instantiate a few new objects from each constructor and then assert its reference. So remember, asserting its reference just means testing it out using that instance of method that JavaScript gives us. And then I gave you a few examples there. So for example, try to create a constructor function for a dog, for a car, for a book. Remember that we're trying to model real world things. I'm looking at a guitar right now. So if I was going to create a guitar constructor, maybe it would be like I'd give it a strings property. So is it a 6 string? Is it a 12 string? Is it a banjo? So does it have 5 strings? You know, what color is it? The make, the model, things like that. So go ahead and take a few minutes and just play around with these constructor functions. So create a few constructors, create some instances of those constructors, and just go a bit of practice with that, then we'll move forward. I'll stop my screen share for the moment. Notation. Then I'll put you guys into breakouts for another exercise. So 2 ways to create an object, literal versus constructor. So literal is pretty much what we've used up to this point. It's totally valid, but if you want to create multiple instances of something, it's probably going to be not very maintainable, or dry for that matter. So if we can use both literal and constructor syntax to create objects, what should we use and when should we use it? What's the use case for constructor versus object literal syntax? Well, they're one and the same, the key difference being when you need multiple instances of your object. So for example, an object defined with a constructor allows for multiple instances of the object. So a constructor, you can call it a model, you can call it a blueprint, but if you want to create multiple instances of something, it's going to be a little more efficient to use a constructor to do that. Specifically, again, on Thursday, when we get into databases and more of a full stack type of application, you probably want to have a constructor for each new user that uses your app, or each new you know, friend or blog article, things like that. You want to create a model for those things. Number 2, object literals are basically singletons with public variables and methods. So I think we've heard that term singletons before. And all that means, there's a quote there, the singleton pattern limits the number of instances of a particular object to just one. This single instance is called a singleton. So object literals are great. They're perfectly valid if you're trying to make, you know, 1, 2, 3 objects. But again, as you scale up, you're going to want to use the constructor pattern for that. And then there's an example in that screenshot. If we just wanted to create an object literal of a person, we could totally do that. We could do a var person equals name Schmitty, and then you could call that variable in Replit or in the DevTools, and it would return that object with the name property of Schmitty. You could totally do it that way. It's just not very dry. Another example of reusing these constructors to create multiple instances of something. So again, using that person as an example, the person constructor function. So create another person, we'd have to write that object literal code out again, or we could use a person constructor function and we could use it like so. Pretty much the example we did earlier with Jenny and Mark, creating new instances of a person. But if we have that person constructor that takes a parameter of name, we could do a var person1 equals new person with the name of Dave, and a var person2 with the new person constructor with the name of John. So just an example of how we can use these.
Is there a way to do the reverse of what you were doing earlier, where you had Jenny is an instance of a person? Can you tell what Jenny is an instance of?
Yeah, if you do Jenny, oh yeah, we're going to talk about that right next here. Right next. How's that for English? Has anyone seen that movie Arrival, by the way? So I watched that this weekend. It's a really good movie, but it's all about language and using language like to communicate with other aliens and such. So yeah, it really hit home for me. Proper grammar and everything. Yeah, so to Mike's point, there's also a method that JavaScript gives us called .constructor. So instead of Jenny instance of person, we can use this .constructor to get to the heart of everything. So let's say we wanted to figure out where a class came from. We can use the property .constructor to take a look at the function that instantiated a new object. So in this example, we could do person, capital P person .constructor, and that will return an object. If you want to try this at home, you could do Jenny.constructor or Mark.constructor, or if you created some new instances of dogs or cars, try that right now. Whatever those objects, if you assign them to a variable, try using that variable name .constructor. And it should look up the chain and see what it inherits from or what the constructor function was for that new instance of something. Now, just broadly speaking, a new function in general is always an example of object in JavaScript. So remember, everything in JavaScript's an object. So if you go up an inheritance chain, we'll talk about inheritance a little bit later, but eventually at the end of the day, everything's going to inherit from this object constructor. So strings come from an object, arrays come from an object, integers, anything at the end of the day kind of comes from an object constructor function. Then the final thing in this screenshot, now if we instantiate the person class with the declarative syntax, we see that the constructor, in this example, constructor Alex, is now a reference to the custom constructor function of person and then with that name parameter. So I'll share my screen quickly and just demonstrate this. Let me start my screen share. Cool, so let me rebuild. I'm gonna try this again in Replit. You guys have probably figured this out. Replit is super duper handy, although occasionally it can be a little wonky at times, but let's try this again. So let me create this new person constructor function. I'll pass in name as a parameter, and then I'll assign the name property, this.name, to that parameter. And then over here, I'm going to create a new person named Alex. Like so. Try that one more time. There we go. Cool. So I have a new object, a new person object, a new instance of a person with the name of Alex. So now I can do alex.constructor. And I can see the constructor function, kind of the factory, if you will, that created this instance of a person. So Alex is actually was derived from a person function. So that's how we can check the constructor. And then another fancy pants way to do this is you could kind of do the reverse. So I could do get prototype of. So I could also do object get prototype. Needs to be camel case. And then Alex. So JavaScript, get me the prototype of this instance of Alex. Let me know what it derives from. It's actually an empty object. But we should get the person object, unless I misspelled something. Well, some Replit goodness. If you guys want to try that in the DevTools, it should absolutely return that person constructor function. So again, 3 different ways if you want to get to the bottom of where an object came from. Yeah.
Question, is it because you didn't capitalize Alex when you looked through the object prototype?
No, so Alex is just an instance of something. I just assigned it to a variable Alex. Now the practice is the actual prototype of person. I do want to capitalize the constructor function, But no, for new instances, it doesn't have to be capitalized. I mean, that's just a basic variable there. So I could create a new person, Mark. And then object get prototype of Mark. Yeah, so maybe Replit isn't very user-friendly with that one. Let me dump this into the DevTools. Just demonstrating that, like, if you want to get to the bottom of things. So let's do a new person. And we'll call this one Mark. And so now, let's see if this works down here. Get prototype of string. Let me pass Mark in there. So there you go. So I see that it's an object prototype, specifically the constructor of person. So again, that's a little wonky. I just want to demonstrate that JavaScript gives us several different ways to kind of trace the where those instances are derived from. So one is .constructor, one is the get prototype of, but kind of the really quick one that I use is that instance of method that JavaScript gives us. That's the one that I use like the majority of the time. So let me stop my screen share. Any questions about those? Alrighty, so I want to put you guys into breakouts and do another exercise, getting a little bit more practice with constructors. So check out the screenshot. So one of the great benefits of using these constructor functions is that we can dry up our code. So let's say, for instance, that we have two variables, one Batman, one Wonder Woman. And you can probably notice that they share some properties and methods, right? So if I'm going to create the entire Marvel universe or the entire DC universe, at some point, I'm going to want to create a constructor function to make my life a little bit easier. So what I want you guys to do, I'll put you in breakouts, see if you can come up with a constructor function of hero that would create new instances of heroes that essentially look like this Batman and and Wonder Woman objects. So what features do Batman and Wonder Woman share? What properties and methods do they share? Remember to think about attributes and methods when you're modeling. So we're essentially creating a model for hero that we can create new instances of a hero out of. So make a hero constructor function based on the above objects, and remember to pass in the appropriate arguments or parameters. So I'll put you guys in our breakout rooms and just see if you can come up with some sort of hero constructor, what that would look like. And let me create some breakout rooms for you guys, and we'll spend 10 or 15 minutes on this. So any questions about this exercise? Okay, we got David and Kieran. So we should be getting close to where everyone has had a unique buddy. I imagine we'll be like repeating buddies here soon. And Sophia and Mike. Cool. Okay, so I'm opening the rooms. We'll see you guys about 10 or 15 minutes.
Can you assign me to the breakout room? I accidentally exited out.
Yeah, let me put you in there. Yeah, see if that works for you. How's it going, Cody?
It's good. Just looking over solutions for Thursday's homework right now.
Yeah, how are they looking?
It's right for the most part. There's just some errors. That updated one, just like some small syntax errors in them that make it not work.
Gotcha. Yeah, that seems to be pretty typical with the start getting into the full stack, right? Little things will just screw you up.
Yeah. How's your weekend?
It was good. I like yeah, we had some folks over on Saturday and then just kind of hung out yesterday and Sunday and yesterday. Watched some Good Wife. How about you? Did you do anything exciting?
Exciting. Yeah, we had a really late Secret Santa. I usually do one like every year with my friends. But you know, as the years go on, your big high school friend group gets smaller and smaller.
Right.
Yeah, but it's still fun to like see people that I don't see on a day-to-day basis. Catch up with them, see what's new. You know, the funny thing is, the State College in New Jersey, that's where I grew up, Rutgers. My friend told me she went to a boot camp there, and it's like 6 months. But I asked her, what did she learn? I think they only learned mean stack, because I was like, oh, do you guys like learn Ruby on Rails? And then she's like, nah. And I was like, oh, how about Python and Django then? Because that's like another big like full inclusive framework. She's like, nah, not really. And she's still like confused on stuff. So I don't know if she got her money's worth. But it's interesting because it's a 6-month boot camp. And
Was
I think
all day, every day for 6 months?
Yeah, probably 5 days a week, something like that.
Wow.
Maybe the homework load is less intense and they dive into like more CS side. I didn't probe it too much, but that would be my guessing since it's offered by a university.
Whew. Man, 6 months.
She's like, I still don't get it. I was like,
6 months? 6 months, you might as well go for the full degree at that point.
Yeah, I don't know. It's because I think she's more into like that film stuff, like doing film stuff. I don't know why she did CS. Maybe just to find a career or something. I don't know.
Yeah, Rutgers has a pretty good like communications department, huh?
Yeah.
That's cool.
Yeah, but 6 months.
That's intense. Definitely need some little breaks here and there in the 6 month class.
Yeah. I think they probably have good placements though, I would imagine.
Yeah.
At least I hope so.
Yeah, Rutgers is a pretty good school, huh?
It's a bad
no
reputation.
Irvine.
Huh?
It's no UC Irvine, but it's a good school.
The surprising thing is, I think in retrospect, if I went there, it would be easier to find more careers. Just because it's a big name school and there's a lot of alumni from it, so a lot of people just work in the tri-state area.
Yeah.
But I don't think anybody has heard of UC Irvine from the East Coast.
Yeah, that's true. But you know what? If you were in Southern California, I mean, there's a ton of Irvine people.
Yeah, that part's true.
And yeah, maybe not nationally. It doesn't translate as well. So I'll share my screen. And you guys can follow along with this if you want. I'm going to do this in the dev tools just so there isn't any replit wonkiness. But go ahead and create a var. I'm going to create a var mark if you want to do your own name. And remember that string, capital S string, is actually a type of constructor function underneath the hood in JavaScript. So let me create a new string of mark. And then if I call that variable mark, so now I see that I have a proper string object. And consider that this is a little more robust than just typing in mark as a string, right? So this is a string as well. But when I did var mark equals new string of mark, it's more of a robust type of object. So this mark with quotes around it, it's considered a primitive data type in JavaScript. So remember we talked about primitives. So your basic strings, basic numbers, your Booleans, they're very primitive data types. There's not a whole lot we can do to them. But when we create a string with this constructor function syntax, it gives us a lot more functionality, just for example. So now if I call mark, the variable mark, not the string mark, and I do length, where is that dot length coming from? Because when I created the variable mark, I didn't define a dot length property, did I? So where's that dot length coming from? Why am I able to call dot length on mark?
Didn't you define mark as an object, or at least a string object, so it gave it a length of 4 because there's 4 letters inside of mark?
Correct. But Alan hit the nail on the head if you look in the Slack. Specifically, I'm able to call dot length because the variable mark is an instance of a string. And so it inherits all of those string methods and properties, and now the variable mark has them. And a quick way to check that out is if I just type in my mark variable again, and I open up kind of the contents of the object. And if you go down to this proto, so for the context of this lesson, you can think of this proto property as pretty much the representation of the prototype. It's pretty much the same thing. But if I open up this proto, check out all of these methods and properties that I have available to me. Notice that they're all properties and methods of a string object. So this mark variable is actually inheriting all of the functionality from a capital S string. So for this variable mark, I could call char at, character at. I could call the dot constructor, which will tell me what variable mark actually was instantiated from. So some of these should be familiar. Includes, index of. So there's nothing really fancy going on here. These are all just string methods and properties. But since I created the string mark as a capital S string, new string, now I can call all of these properties as inheriting those properties and methods from the string object, which is pretty cool. So if you scroll down here, you can see that most of these should be familiar, right? So slice, split, starts with, substring. So now my mark variable has all of those available to it. And then like we talked about earlier, I can do mark.constructor. And I can see that it's the constructor function was a string. I can also do mark instances of string. I get true. And then here's a really fun thing. If you want to hack your JavaScript code, the way that you can add, we're going to take a look at this after the break, go a little bit deeper. But the way that we can add new methods and properties to a constructor or to instances of that constructor function is by using its prototype object. So for example, we can actually hack that JavaScript string constructor and actually add a new property to it if we want. And the way that we're going to do that, again, we're going to look more into this after the break. So let's say that I wanted to add to the string prototype I'll say that I wanted to add a property of Schmitty. And then Schmitty is going to be like, hey, WDI, something like that. So I just added this property of Schmitty to my string prototype. And since the variable mark inherits all of that cool stuff from my string, now I can call mark.schmitty, and now it will return that new property that I just created. And if I go into mark, and I open up the mark object, and if I look at its proto/prototype, now Mark has this really goofy new property called Schmitty attached to it that I can call on the Mark. So we just hacked our JavaScript. So now, in addition to character at and length and such, we also have this .schmitty property that we can call on any string that we create. So let's say that I create a new one, Cody equals new string of Cody. Now I should be able to call Cody, and now Cody has inherited that new Schmitty. So consider if I had hundreds, thousands of string instances, and I wanted to add one new property to all 100 instances that I had. It's going to be pretty. It's going to be a pretty big headache if I go through each one and add .schmitty to Cody, .schmitty to Mark. But what I can do, because of the beauty of JavaScript and this inheritance, this prototypical inheritance chain, is that I can attach new properties and methods to the prototype for string, and then it'll cascade down to every instance of that string object, both new instances of the string and existing instances of the string. So it's a pretty kind of a beautiful thing that the language has at our disposal. So let me stop my screen share. We'll put a pin in it right there. I'm sure you guys have some questions. So we'll take a little bit of a break and get you guys to some more lab time. But let me address Audrey's question. So Audrey asks, I understand this is a more robust way to define our objects. However, if I define a string in the primitive way, doesn't it still also have those capabilities of string? It does, yeah. It has some of the basic, it has length and split and all that. And actually, I'm just using string as an example. Most of the time, you wouldn't want to create like a new instance of a string using that object, using the constructor for a string, because it takes up more memory. So if you're creating a bunch of strings, usually the primitive is going to be fine. But this is just an example, and we'll take a look after the break. This would really come into play as I create new person objects, new instances of a person. So let's say that I create 100 new people, and then down the line, maybe I want to add, a property of, eyes. And every person by default, I'm going to give them 2 eyes or something. Then instead of going through all 100 people and adding a .eyes property, all I have to do is add that new property to my person constructor, the person constructor's prototype object. And then then all of the new instances, all existing instances and all new instances will inherit that eyes property. That's what we're going to do after the break. We're going to play around more with that prototype, but that's kind of the gist of what it is. It's an object with properties and methods that all instances of a given constructor function will have available to it.
Okay, so I just want to, I'm sorry, I just want to repeat so that I know that I'm understanding it very much the same way you're saying it.
Sure.
So pretty much the constructor allows a little bit more flexibility to go through all your objects and add a different prototype to it that may not have been there before.
Well, so it's 2 different things, and that's why JavaScript is a little, it's not quite as simple as other languages. But to create new instances of an object, there's a constructor function, and then there's the prototype for that constructor. So the constructor function contains all of the initial values that you want that particular person to have. In our person example, the only thing that we've added out of the box is like a this.name, right? But there's a lot of other cool stuff that we could add to a person. So let's say that today we create 100 new people, new instances of that person, and they all have a dot name. Well, that's not that exciting. And let's say the next week, we want to add some more properties and methods to a person. Maybe we want to add a person.speak. So when I call person.speak, it says, hello, my name is such and such. Or again, maybe I want all of my people to have an eyes property of 2, or, biped property, or, something like that. Then the way I could add those properties and methods down the road is by adding it to its prototype. So I don't have to go back and add it to each individual instance. I can add it to this other thing called a prototype that every constructor function has, and then it will kind of cascade down to all the instances that I've created of that person. Hearing me talk about it isn't that exciting, or it may not be completely clear, but after the break, that's what we're gonna do. We're just gonna focus on prototypes and playing around with what capabilities the prototype gives us. And so maybe it'll be a little bit clearer after the break. Hope that answers your question somewhat. So let's do this. I wanna give you guys a little bit of a break time, and I have another quick exercise for you. So go ahead and take 15 minutes, go and stretch the legs, do what you need to do. We'll come back at 1 p.m. And while you're on break, go ahead and take a look at this hack the JavaScript string constructor exercise. Again, just playing around with what I just did. So create an instance of a string using the string constructor. Then using the strings.prototype, add a property that will return WDI rules or some message of your choice. And then check out the new property on your instance's proto in the dev tools. So there's a really small difference between proto and prototype. Just know this, when you look inside the dev tools, the prototype, the way you find it is that it's under this proto property on any given object. It's a little wonky. We'll talk more about it after the break, but that's just how the language is set up. There's a subtle difference between the two, but for all of our stuff today, we can just think of them as the same thing. So we'll come back at 1 p.m. We'll continue our prototype discussion, and I'll see you guys then. Hop into it. I'm going to do this in Replit. I think we'll be fine for this section. But I refreshed my Replit. I cleared out the right-hand side, so I think we'll be fine. Because I want to be able to see at a glance all the code that we're going to write over here. So if you want to follow along with the screenshot that I put into Slack, so I have this person constructor function that we've been playing with this morning. And if you want to follow along, let's create 2 instances of this person. Let's create a mom and a dad using our person constructor. So I'll create a mom variable and a dad variable. And one will be an instance of a person named mom. One will be an instance of a person named dad. So if I run this code, just to kind of sanity check this, so now I have a mom and I have a dad. So 2 instances of this person constructor function. Now, Up to this point, the way that we've wanted to, if we want to add information to our existing objects, we can use dot notation. So for example, if I want to add nationality to mom, a nationality property, I can just do it using dot notation, right? So mom.nationality equals British. So now if I call my mom, it has a name property and a nationality, but dad still only has that name property, right? So I added a property specifically to my mom instance of my person object. And that's cool. And then I can also, so that was a property. What if I wanted to add a method of speak to my mom? I could do that. So let's say I want to do mom dot speak equals a function. And when I call this function, I just want an alert of hello, just for example. Oh my goodness, didn't close out my deal. Let me try it one more time. So I'm gonna do mom.speak. I know it's a Tuesday, but it feels like a Monday. So we'll just say hello, like so. So now I can call mom.speak. I have to actually call it. And then I have a little pop-up window that says hello. But again, I'm only adding that method to my mom. So if I call mom, it has a name property, a nationality property, and then a speak method. And then my dad still only has that initial name property. So again, just a quick demonstration of this is how we've been able to quickly add properties and methods to an object just using dot notation. But let's see, what if I wanted to add nationality to both my mom and my dad in one fell swoop? What if I wanted to add a speak method to both my mom and my dad with just one command? I didn't want to add it individually. Let's see how our prototype object can help us with that. So this is our next little step here. Let me go ahead and clear this out so we can rerun it. So now I'm still going to instantiate a new instance of person, one named mom, one named dad. But now let's see how we can add properties and methods via that prototype. So right down here, just so we can see it, I'm going to add something to my person prototype. Let me close the console down there. Cool. So person.prototype. So remember that the prototype is the object that every instance of a person will have access to. And this prototype object consists of all the methods and properties that all the person instances will share. So I'm going to do person.prototype, and then I'm going to attach a property to this prototype specifically. So let's do prototype.species. So I want every person to have a species property, and we'll make that property human. So go ahead and save this and run it. And now if I call mom and dad, notice that out of the box, we don't see those prototypical properties. So they exist, but they're under the hood. But I can do mom.species or dad.species. And they're there. They're on the prototype. So this name is considered an instance property because we defined it in the constructor function, right? So this would be considered an instance property. This is a property that we can see, if we just call up the variables. But the species property is attached to the prototype object specifically. So we don't see it right out of the box. The way we could see it is if we were in our dev tools And if we looked at the proto, so remember we mentioned in the dev tools that proto property is essentially the same thing as our prototype object. So if you wanted to do this in the dev tools and you opened up the the proto object, you could see all of the prototype properties and methods. And that's where that species property will live. But again, this is how we can add properties and methods to instances of that person after the fact. So it'll apply to future instances of person and also past instances that we've already created. So it's a really handy feature. Any questions about that? Yeah, go for it.
So because we don't, even though we can't see it, because it's under the hood, we can still utilize it later on in like other functions or something like that. Like if I needed to like do something, just random example, like if else the species equals human, then assign something to them, versus like if it was like species came up dog, don't do it, even if I don't see it because it's under the hood.
Yeah, and let's do this just to demonstrate that. Again, I really like Replit. It's just easier to maneuver. But if you have your code working in Replit, let's just copy that code and dump it into DevTools, and we'll see it down here. So let me see if I can make a little bit more room. So yeah, go ahead and clear that out. I'm just going to grab all of this garbage and dump it down here. And so now we should have a mom and a dad. Okay, so just call up mom or dad and then go ahead and open up the object. And you'll see that again, in addition to the instance method of name, instance property of name, we also have this prototype object. So if you open up the prototype object, that's where you'll see that species property as well. So any methods and properties attached to the prototype, again, can be found in the DevTools under that proto property. And then there's our constructor property as well. So remember, if we do mom.constructor or dad.constructor, it'll tell us what the constructor function was for that instance. And so there's our constructor right there. So you can even open that up and get a little bit more information about the constructor function of person if you want. So you can see that it's called person. It also takes in a parameter of name. So you can get a little bit more specific about that. And then if you really want to get wonky, this is a little outside of the scope of today's lesson. But again, you can go up that prototype chain. And so you can see that person is actually an instance of an object. I mean, everything in JavaScript is an instance of an object. And remember that above an object, we just get null. So if you went up the chain, eventually a string, an array, a number, a Boolean, at the end of the day, everything's going to be an object. That's kind of like the God particle, you know, at the end of the day. But yeah, so you have properties and methods that you can define inside your constructor function, and you have properties and methods that you can define on the prototype object. And all the prototype is just a fancy object that all instances of a person will inherit from. And let's take a look at one more example while you have this code pulled up. And we'll just add a method to that. So if you want to add, we're going to add a speak method, just another example. And while that's loading up, there you go. So down here, let's also add a speak method to this person.prototype. So I'll do a person.prototype again, and we'll call this speak. And this is going to be a property. So in here, we'll do another goofy alert. But specifically, let's make this alert the name of the specific instance that we're calling it on. So we'll do something like, my name is, I'm not using template strings, just going to use some concatenation here. And then we'll do name. So remember that this name is going to be the this.name for whichever instance we call it on. So it'll be my name is mom, my name is dad, according to that specific instance. So let's see this in action. I'm gonna go ahead and load this up one more time. Let me clear it, make sure there's no wonkiness. And I'll run it again. And so we have, oops. So we have mom, we have dad. And now we can do mom.speak. And you can see the goofy little alert, but it's saying my name is, it's not printing out her name. Why are you not printing out your name? Maybe it's added this there. I'll try one more time. So now, there we go. I forgot to put the this on there. So if you do, my name is this.name, it will grab the specific name property for that instance of a person. So now we can do mom.speak and I get that goofy little alert. My name is mom. And then I could also do that with dad, of course. Dad.speak, my name is dad. And then both mom and dad still have that species property, like so. So this is a really great, again, just a really great feature of the language, and that we can attach extra functionality to that prototype and it'll cascade down. It's inherited by all of the subsequent instances of whatever constructor function that we create. So it's a very flexible, dynamic way to scale up our code in JavaScript. And it's also a very dry way to write our code, which is really kind of the greatest feature in my opinion at the end of the day. So I'm going to stop my screen share. And before I put you guys back into another exercise, is there any questions about that? I hope that was a little bit more actually kicking the tires with the prototype. You can kind of see what it does for us. Okie dokie. So I have 2 exercises for you guys, and this will take us to lunch. So I'll put you guys in the breakouts, and we'll be on the honor system that you'll work till 1:30. Just getting some more practice with what we've gone over today. So practice part 1, and you can do all these in Replit or the DevTools if you want. So just want you to create a new army of soldier objects. So you'll want to create a soldier constructor function for part 1. And then those are 4 kind of criteria for your constructor function. So each new soldier will create the constructor function. Each soldier should be able to have a name and a number. The default type of a soldier should be foot soldier. And then each soldier in the army should have the same battle cry, which would return an alert of freedom. And then part 2, if you get through that one, again, this Colin's gonna be kicking this up a notch tomorrow when we talk about data modeling and creating models and constructors as we get into databases on Thursday. And so part of that data modeling is actually modeling your real life objects. So for part 2, if you have time, I want you guys to talk about creating a constructor function for playing cards, for a deck of cards that have the following attributes: a suit and a card value. But kind of the bigger point of that one is to think about how you would write code that would replicate real life objects, right? We talked about that earlier. If I was going to create a dog constructor function, how would I want to scaffold that constructor function, or a book constructor? Anything like that about modeling real life objects. So any questions before I put you guys into breakouts? Okay, cool. So you guys can work on this until 12:30. We'll see you guys back here at 2:30, and we'll talk about promises this afternoon. Okay, so I'll open up the rooms. We'll see you guys 2:30.